Today we're going to talk a little bit about where some of that data that we've been organizing into graphs comes from, and we're also going to practice making some predictions a little bit more. All of this data that you've been organizing into histograms and line plots and stem and leaf plots, that data has to come from somewhere. One place that data tends to come from is surveys. So a survey happens when you go out and you ask a bunch of people a question or you collect data from them. The part of your lesson that you should have already completed before starting this video, the before you watch part, you were given a situation and you were asked some questions about it. We're going to take a minute to check in with those questions before we talk about your notes. Your first question said, suppose you decide to survey listeners of a rock radio station about music preferences. Do you think this would represent the entire population? The correct answer to that would be no, because if you're surveying people from a rock station, they're probably people that like rock music. But there are lots of other different types of music that people might like. Some people might like country music best, or classical music, or pop music. So if you really wanted to get a good survey, you would need to survey people that listen to lots of different types of music, not just rock music. The second one, suppose she decides to survey a group of people standing in line for a symphony. Do you think this results would represent the entire population? For the same reason as the last problem, the answer to that really should be no, because people who are standing in line for a symphony are probably people that don't mind or like classical music. So you probably are going to get some biased opinions. People who are standing in line for a symphony might be more likely to have ringtones that are classical music songs. So it's the same problem as the last way of getting the data. You would need to survey people standing in line for a symphony and standing in line for a rock concert. So you would need to get lots of different types of people. The last one, suppose she decides to mail a survey to every 100th household in the area. Do you think the results would represent the entire population? The answer to the third one is maybe. So she does a better job of getting variety, because if you're doing every 100th household, you're a lot more likely to get a variety of people. So people that like different types of music, people that are different ages. So some houses might have seniors. Some houses might have college students. So you're going to get a lot more variety that way, which is good. The reason that that's a maybe and not a yes is because that survey does have one problem. You're mailing the survey to people and you're asking them to complete the survey. You're relying on people to turn the survey back in, and not everybody is going to do that. So only people that have maybe a strong opinion about it are going to be more likely to turn it in. So you might only get a certain type of people turning that in. So that's why I would say that would be a maybe. So number 1 and number 2 from your before you watch probably would be no. Those ways of getting the data would not represent the population well. The third one might. So what that's getting you to think about is different ways of getting data. When we have a large group of people, we call that a population. We don't ask every single person in the population for their opinion. Usually we'll only ask a few people. So a smaller group that's chosen from a larger population we call a sample. So if you want to get information about everybody in Portland, you're not going to ask everyone in Portland. That would be very overwhelming. What you'll probably do is take a sample. So you might ask some people from around the city, whatever you want to find out, and then use those people to represent everyone. So that's what a sample does. So depending upon how you get your data, which is what we were just thinking about, you can have data that either represents the population well or does not represent the population well. So a sample that represents the population well, we call an unbiased sample. and it would give what's called a valid conclusion. So in other words, if you have an unbiased sample, so you have a group of people that's doing a good job of representing your population, making predictions with those group of people are probably going to give you pretty accurate results. One of the best ways to get an unbiased sample that's going to give you a valid conclusion, or in other words, give you nice, accurate results, is a random sample, or we call it a simple random sample. So a simple random sample is any sampling method where everybody in the population has an equal chance of being chosen. So if you were collecting data about everybody in Portland, you would want to come up with a strategy where everyone in Portland has an equal chance of being chosen. So maybe you might look at the census data or the population data for Portland and choose every 100th person. So maybe you might choose every 100th person registered to vote. You're going to get a big variety that way. When we are done watching, you're going to go back and you are going to see if you can come up with your own example of a random sample for a situation. So I just gave you an example. So if you wanted to try and get a random sample of people that lived in Portland, maybe you could go through the voter registry or the driver's license registry if you wanted adults only, and randomly choose people from there. And that would give you a wide variety without excluding any adult residents of the city. So you're going to see if you could come up with your own example of a random sample, and you're going to record it right there. When I check your notes, I'm going to check to see if you have that filled in. So random samples are a good way to get unbiased data that gives you valid conclusions. In other words, random samples are a good way to get data that represents your population and will give you good predictions. Now, when we were talking about the surveying people about music for ringtones that you did before you watched this video, there were a couple of ways that were not very good ways of getting the data. So a sample that does not represent the population, that's called a biased sample. And it results in what we call an invalid conclusion. In other words, it does not represent the data accurately. So some examples to give names to some of the sampling methods that were in that intro before your video. So one of those was a convenience sample. So convenience sample is where people get to choose, so a convenience sample is basically you're surveying people that happen to be nearby. So the reason why it's called convenient sampling is because convenient means easy to access or easy to do. So if you're surveying people nearby, that's convenient. So an example of that might be if you wanted to find out people's favorite lunch at Pilgrim. Maybe you might ask the people that are in class with you. They're in class with you, they're right there, it's convenient. So that's convenient sampling. But it's not a very good sampling method because if you only ask the people that are in class with you, then you're not going to get the opinions of any of the other classes or any of the other age groups in the school that might have different opinions than you. So that's one example. So ask the people that are in your class with you. Again, it's invalid bias sample because you're excluding, you're not giving all the other ages and grades a chance to answer. You're going to see right here if you can make up your own example of convenience sampling. So you're going to invent your own example of something that would be convenience sampling, and you're going to write it down right here. And I will check your notes when you turn your notes in to see if you have that filled in. So coming back to our song example, the one where you're surveying everybody standing in line for a classical music concert, that would be another example of convenience sampling. Everybody's already in line and you're right there in line with them, so let's just ask them while we're there. Another example of something that you do not want to do because it will not give you good, accurate data is something called voluntary response sample. So voluntary response sample is where people are allowed to choose whether or not they can participate. So people choose whether to participate. So the example, an example of that might be if you post a survey online and you tell people, hey, come take my survey. You're leaving it up to them whether or not they respond to your survey. So that's voluntary response sampling. It's not a very good sampling method because when you let people choose, that doesn't guarantee that you're going to get lots of different groups of people or a variety of people. So it's not a very good sampling method. So again, you're going to see if you can come up with your own example of voluntary response sampling to show me that you understand what that is. And you're going to write your example that you made up right here, and I'll check it when you check your notes. So we mentioned this a couple of times, but only valid samples can be used to accurately predict. So if we had data that was collected using convenience sampling or voluntary response sampling, we would not want to try to predict with that data because it would not likely give us an accurate prediction. If you do have a valid sample that you've collected using random sampling, then you can predict. And the trick to predicting is to use something we've already been using, and that is proportions. So we're going to look at one more problem, and it's not on your notes outline, but it's something that we've already been doing, and I want to review it with you quickly so that you can do a little bit of practice with it and also connect it in with what we were just talking about. So this is an example of a predicting problem. An office manager randomly surveyed 60 employees to determine whether or not a vending machine should be placed in the break room. 45 of the employees said yes and 15 said no. If there are 255 employees in the building, predict how many employees would like a vending machine in the break room. Now, before we even try to predict, we need to make sure that our data is valid data. And the thing that tells us it's valid data is right there, that word randomly. So that tells us, okay, we used random sampling, and random sampling is a valid way of getting our data. So if we were using one of these invalid ways, convenience sampling or voluntary response sampling, then we would want to just stop. And rather than trying to predict, we would say, we're not going to predict because the sampling method is not going to give us accurate data. But because we randomly collected this data, we can say, okay, randomly surveyed employees are probably going to represent the group pretty well. So we can use a proportion to help us figure out our prediction. So 60 employees, 45 of them said, yes, we want a vending machine. So that's 45 people out of 60 people total. And the way predicting works is we didn't ask all 255 employees. We only asked 60 of them. So we're going to take this amount that said yes, and right now it's out of 60 people. We're going to scale it up to see how many out of 255 people would answer that same way. So from there, you could go through and you could solve your proportion. A lot of people like the cross-multiply strategy for solving. So if you remember how that strategy works, we multiply diagonally. So 60 times x equals 45 times 255, which is 11,475. And then all we have to do is just divide. Now, one thing, that's another thing when you're predicting based off of data you've collected, If you solve this proportion, the actual answer is 191.25, but we're talking about an amount of people. And we know that we can't have 0.25 or 1/4 of a person. We're not going to saw a person into quarters. So you need to stop and think about your units. And if your units, fractions, and decimals don't make sense, then you should round. So our final answer, we could say about 191 people. So this part of predicting, you've already practiced in some other ways, and you've been using it to do some other things in this chapter. The piece that we're adding in is how we're getting that data. So you need to stop and look at, how am I getting the data? Because if I am getting the data from one of these biased methods, convenience sampling or voluntary response sampling, then I really shouldn't be predicting with that data, because that data is not going to represent the population correctly.